and wing anti-ice. The A320 pneumatic system provides high-pressure air to various aircraft systems. Some of the more common systems that operate with high-pressure air are the air conditioning, engine starters, and wing anti-icing. In addition, the pneumatic system provides the air pressure to pressurize the potable water system and the hydraulic system reservoirs. The pneumatic system can receive air from one of three sources: engine bleed air, APU bleed air, or an external ground source of high-pressure air. The pneumatic system controls are installed on the air conditioning panel. There is a bleed switch for each engine and the APU, and there is a rotary switch for control of the cross-bleed valve. This diagram shows the pneumatic system consists of a left and right side that is manually or automatically connected by a cross-bleed duct through a cross-bleed switch. During normal operations, the cross-bleed switch is in auto, the APU bleed valve is closed, and the cross-bleed valve is closed. In this situation, each engine supplies bleed air to the respective side of the pneumatic system through the engine bleed valves. The APU bleed air or ground air source connects to the left side of the pneumatic system. Thus, the cross-bleed valve must be open to supply APU air or ground air to operate the right pack or to allow engine number 2 to be started. If the APU is running and the APU bleed is on, with the cross-bleed switch in auto, the APU bleed valve opens, the cross-bleed valve opens, and the engine bleed valves close. Thus, the auto position of the cross-bleed switch will automatically close the engine bleed valves and open the cross-bleed valve whenever the APU bleed valve is open. With the engines running and the cross-bleed switch in auto, when the APU bleed is off, the cross-bleed valve closes and the engine bleed valves open. The auto position only functions in conjunction with the APU bleed air. If ground air is applied to the pneumatic system, the cross-bleed valve is opened manually by selecting cross-bleed to open. The auto position does not function for ground air supply. If only one engine is the source of air, and the crew desires the cross-bleed air to the opposite side, the cross-bleed valve must be manually opened by selecting the cross-bleed switch to open. The auto position does not function to cross-bleed engine air from one side to the other. Okay, let's discuss the devices that provide control over this system. Two bleed monitoring computers, or BMCs, are installed. They provide automatic monitoring and control of much of the system operation. The BMCs receive information about bleed pressure and temperature and valve position. Examples of items monitored by a BMC are the engine start valves, APU bleed valve, duct leaks, overheat, and overpressure conditions. The BMCs use this information to determine logic for control of the engine bleed valves. Each BMC is connected with the other systems that use air or information from the bleed system and is also connected to the other BMC. Each BMC supplies indications and warnings to the ECAM and CFDS. If one BMC fails, the other BMC takes over most of the monitoring functions. Engine bleed is provided to the pneumatic system through the engine bleed valves. Each engine bleed valve is controlled by a bleed switch. The engine provides bleed air from one of two stages. The normal supply of air is delivered from the intermediate pressure stage, or IP, of the engine's high-pressure compressor. The use of IP air supply for normal conditions provides fuel efficiency. While the engine is at low power settings and the pressure and temperature of the IP supplied air is not sufficient, the high pressure stage provides bleed air automatically. The high pressure stage provides this additional bleed air pressure when needed and maintains the air pressure at 36 psi plus or minus 4 psi. While the high pressure valve is open, its air pressure is higher than the IP stage pressure. Therefore, a check valve is installed to prevent backflow of the high-pressure air into the IP stage. The high-pressure valve may be closed automatically by either pneumatic or electrical conditions. The engine bleed valve is downstream of the IP and high-pressure valves. It is used to turn on or off the delivery of bleed air from the engine and to provide pressure regulation to the air supply. Now, each engine bleed valve is electrically controlled and pneumatically operated. That means the valves must receive an open signal and have engine bleed air pressure in order to open and regulate. The signal control is provided by the associated BMC. The engine bleed valve limits the delivered air pressure to about 44 psi plus or minus 4 psi. However, you may see more or less pressure at high thrust settings. This is acceptable as long as cabin pressure is normal. The engine bleed valves will close if APU bleed is selected on. When APU bleed is selected off, the engine bleed valves will automatically open if they are selected on and the bleed air pressure is available. This frame shows the engine and APU running. Turn the APU bleed on and off to see the effect. The engine bleed valves require pneumatic pressure and an electrical signal to operate. The valve will automatically close because of either pneumatic or electrical actuation. During abnormal conditions, an engine bleed valve will also close. For example, the engine bleed valve will automatically close if the downstream pressure is above 85 psi. An air-to-air heat exchanger is installed downstream of each engine bleed valve. This heat exchanger uses cooling air from the fan stage of the engine to limit bleed air temperature to 200 degrees Celsius. The fan air valve controls the flow of fan air as necessary. In the absence of air pressure, a spring keeps the fan air valve closed. Bleed air provided by the APU does not have an air-to-air heat exchanger and temperature regulation. Therefore, APU bleed air should never be used for wing anti-ice because the slats may be damaged by excessive heat. Now, let's answer some questions.